In this tutorial, I'm going to show you how to use the model builder. It is an original tool that is going to let you design your own binding models from scratch. So in order to access the model builder, go to the main menu and select the option models. Click in the bottom of model, and a new window will pop up, that is the reaction builder. So how can we design our own binding models? Well, AFFINImeter uses what we call the MaB code. This means that the species M is the species that is going to be always in the cell. A is going to be always the species in the syringe. And we have a third species, B, which can be in the cell, in the syringe, or in both places at the same time. B would be what we call a co-solute, or for instance, a competitor that is involved in the interaction. So how do we use this MaB code to generate our own binding models? So it is very easy. We just need to drag and drop the species we want to be participating in the interaction into the reactive box. So we just drag and drop the M species. Now I will drag and drop the A species. With this, I just generated the standard one-to-one interaction where the species M in cell is going to interact with the species A in syringe. If we click in Accept, we will visualize this first equilibrium in the model builder. So we can go further. We can add more equilibria to our binding model. We just need for this to click in free species if we want our new equilibrium to start from free species. Select one of the arrows and drag and drop the species we want to participate in this new equilibrium. For instance, I'm going to consider that the species A is forming a dimer in the solution. So for this, I drag and drop the species A into the reactive box. And now I define the stoichiometry that is going to characterize the new equilibrium. In this case, 2, because I am considering that the species A is forming a dimer in solution. So I just created a very simple binding model, which implies that we have a one-to-one binding interaction between the species M and the species A, and also I am considering that the species A is forming a dimer in solution. So this is a very simple model of a situation that is not rare to find in binding interactions, but we don't have this binding model available as a standard binding model. What I'm trying to explain with this is that it is very frequent that we are going to need tailored binding models to give explanation to our experiments. And you can do this with the model builder. So let's do something a little bit more complicated. So let's consider that our binding model involves a competitive interaction. So we are going to drag and drop the species M, the species A, to generate the first interaction, one-to-one interactions. And now we are going to consider that there is a species B that also binds to M. For this, we will drag and drop M and B to the reactive box to consider the presence of this species B competing with A for establishing an interaction with M. Let's consider now that M has two binding sites, and these two sites can bind with A and with B. We are going to click in MA to generate the next equilibrium, and we will introduce a new molecule of A to generate the complex MA2. Additionally, B is going to be able to bind to the second site of M, and we are going to draw the corresponding equilibrium by clicking in MB, selecting an arrow, and then including a second molecule of B to generate the species MB2. We also have to consider another complex that is a complex that involves the interaction of M with a molecule of A and also with a molecule of B. And for this, we are going to click in MA, select an arrow, and draw the complex MAB. So with this example, my objective is that you understand that when designing a binding model, we have to draw all the complexes, all the intermediate species that you think are going to participate in the interaction. In this case, we have a competitive experiment where two molecules, A and B, interact with M, and besides, M has two sides. So these are all the possible complexes that can be formed in the media. When the time comes to save the model, just name the model and save it. You can visualize or edit anytime the models you design, because they will be kept in your database of models in AFFINImeter, and you can use them whenever needed.